Okay, let's get down to it. All right, so how does the image compare with the object? Now you can see here, this is converging lens. How do we know that? Because if you were to draw a dotted line here by extrapolating from this one, you can see that the ray bends towards principal axis. All right. And then you can see that if you draw a line back, has been drawn, you can see that the image is formed here. So based on the types of images that can be formed, you know that notes with the tables, and then you have like different distance from the optical center, you can deduce the type of image formed. So what is this actually? If you see dotted lines, these are virtual rays, which means that it is, well, they don't have any of this here. Secondly is upright. And thirdly is bigger or magnified. So B will be the right answer. Okay, and what's the application for this? Magnifying glass. All right, moving on. Which equation is used to define resistance? Interesting. What do you guys think? So we have energy equals to I squared RT. I think first we need to actually define resistance. So resistance is defined as ratio of potential difference across a component to the current flowing through it. So which one will give you the answer? So if you look at this, doesn't seem like there's potential difference and doesn't seem like, well, there's current, but even though this formula is correct, but there's no mention of potential difference. So it's out. Again, for this one, formula is correct, no mention of potential difference. The last one, formula is correct, but it's about resistivity. This is based on physical properties of the wire. Physical properties refers to area, length, resistivity. So that is not it. So you're left with B based on the definition. Okay. So moving forward, this is under statics. All right. Which statement is correct? Student disconnects the Irving wire. Okay, you got to read this carefully first. A metal rests on an insulator. Okay. Then removes the positively charged. So disconnect first, then remove. It's very important because when you remove first and you disconnect the earthing wire, the results will be different. So when this happens, as of now, if you see the diagram, you'll get negatively charges induced, okay? And the positively charges wants to move out. You have an earthing wire here. So let's draw some positive charges. The moment you earth, electrons will flow in and they'll come to discharge these guys. So they'll be gone. Gone, 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 gone. Okay. But if you, okay, so if you remove after this, you will get negative charge. But if you remove the rod first, okay, you will have all these negative charges flowing out because the rod is no longer there to hold the charges into place. These negative charges have a free will on their own. They are like crazy, wild children left to do their own things, running around out the earth wire. Okay, so if you remove the earth wire first, metal plates becomes positively charged. That's not possible. As mentioned, you will get a negative charge here. All right, so this will be correct. Let's look at the rest. Plastic rod is removed first. Again, none of this will happen. The true answer will be, it will be neutral. Because the negative charges will leave the plates. Will leave the plate. Will leave the plate. Okay, moving forward. Oh, this is quite okay. So you get something like this, and this, and this. Okay, an uncharged sphere doesn't mean that there isn't any charge at all. Uncharged sphere simply means that there are equal number of positive and negatives. So when you put the positively charged sphere near to it, it will cause the negative charges to move towards the positively charged sphere, and it will cause this right side to have a positive charge induced. Okay, so basically at the beginning you will have equal number, but suddenly you have some negative charges moving towards one side, and then you have positive charges moving towards the other side. They should be equal in number. So this is correct. So count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right. So this will only be correct if you have Earth. But if there isn't Earth, then this is not correct. Okay, this one should be quite straightforward. Answer is D, can be found in your notes. Um, not ready for this yet, but the answer should be C. We'll go through it later, next time. Okay, let's take a look at this. The first one is the X-ray. So the thing about X-ray is that the emitter is here and the receiver is there. But the thing about this is ultrasound scanning. So ultrasound requires a reflection of the sound wave. So the emitter or the transmitter is here. It will send the ultrasound signal into the body, of which it will bounce back to the receiver. So the emitter and receiver are at the same position, whereas the receiver is here. The receiver is a fluorescence film. So because the X-rays will hit the film, and the film has a special material that produces fluorescence. All right, so that will look something like this. This is for the X-ray, and this is for the ultrasound. Quite obvious lah. I mean, the baby isn't going to look like that when you scan it, but yeah. Okay, so let's see which combination is correct. So P is for Y that is possible wave used in column 1. Wave used in column 1. Oh, for the P. X-rays is correct. Medical examination Q. Picture X. Okay. Yeah. So let's answer is A. Sounds simple. Let's move on. So again, you have an echo. It's the bouncing of the sound off the wall. And now we have the source. So when you see houses like this represents the source, the sound that is being produced. And this is the echo after you bounce back from the wall. Echo by definition is the bouncing of sound. So that echoed pulse that you get must be bouncing back from the wall. So you have this, one division here represents 0.01 second. Okay, you should be taking the midpoint from here to here. So you count 1, 2, 3, 4, 5, 6, 7, plus a half here, that's 8. So we have 8 divisions, and that gives you 0.08 seconds. They ask for distance. Now, if you're thinking to use this, I would say there'll be a mistake here because this is the echo. Echo is 2 times the distance because the distance that you produce here is considered as D, but it will bounce back. And that's another D. So you need to put a 2D here. And the rest is just math. Okay. What's 24 divided by 2? 12. It should be this one. All right. Moving forward. Statement about water wave is correct. Amplitude is the vertical distance between a throw and a peak. No. Amplitude is the maximum displacement. That would be half of the vertical distance. Because vertical distance would be like this. Whereas the amplitude will be here. So number 1 is wrong. Frequency is the number of throws passing a point in 1 second, added to the number of peaks passing a point in 1 second. If you were to remove this, then the answer is correct. So that means this answer is not correct. Speed is the horizontal distance traveled per second by a peak. That's possible. Wavelength is the horizontal distance between a throw and a peak. A throw and a peak will be here. And that technically gives you half a wavelength. So that's not correct. So answer C. Yay. Moving forward. Speed of the wave, L apart. Okay, what's the expression of frequency of the wave? So this one here gives you half a wavelength. The reason being is because you have a compression to a reflection. So that gives you half a wavelength. A compression to a compression gives you a full wavelength. Frequency of a wave, speed is V, so V equals to F lambda, F equals to V over lambda. What you see here is 2L. So V over 2L, because lambda is 2L. L here is half a lambda. So lambda will be 2L. Done. Okay, on to structured questions. LL. Show clearly how by drawing a light ray. Okay. So this requires a bit of a two-dimensional. All right, there we go. Okay. Um, so we can use this first. So this light ray will reach here. Then we go down there. Okay. So this is the top of the object. So top must end at top lah. If you are light ray, you come out here and then you end at the bottom, that doesn't make sense. There's no logic. A light ray bouncing off the top of the object must form the top of the image over here. Okay. So from here, you can simply get the focal point or the visible focus. Okay. So draw a light ray. We're done with this. Describe the image form on the screen, the nature of the image. The nature is real. Okay. Because you can form on the screen. So that means it's real. It's inverted. And if you take a ruler and measure, it's about the same size. So they may ask you certain things later on. Oh, that's another topic altogether, another question altogether. All right, let's move on. It's important to take note that if this is F here, then here to here will be 2F because image are the same size. So for same size, the distance will be 2F and here also will be 2F. That is the properties of same size image. Define the focal length of converging lens. I think that's the standard definition question. It's a distance between the principal focus and the optical center. The lens. There we go. Estimate the focal length of the lens. Okay. Must be adequate. So you will need to draw this inside. And then you can continue this one. Because the plastic, this is the one that causes the light to bend. So you just have to extrapolate a bit and you measure this distance from the center. Measure this and that should be your answer. So this depends on how you print the paper out. If you print half of A4, then the answer will be smaller. This is 10x scale drawing. So whatever answer that you get here, example, maybe you got 6 cm. You go to times 10 because it's a 10x scale. So I'm going to just roughly put this as answer. Describe what happens to the light as it enters the plastic disc. Keywords to mention. Enters an optically denser medium. That's the first one, bends towards the normal due to a change in speed. So you get 2 marks, 1 mark for each. You're asked to describe, so that's about it. Complete to show the light, the rays of light inside the plastic disc. Hmm. You have to find the angle first. Okay, so this is a scale drawing. Uh, there's a bit of work to do here. First thing you want to do is to find the angle first. You need to find this angle. Once you found the angle, then you will need to use the same angle. So it'll be something like that. Okay, find this angle first. Then you get something like this. Because it's the same block, right? So if you are, oh wait, you gotta find this angle as well. Because by geometry, this angle will have changed if you have gone up. So you need to find this angle, and you will need to use Snell's law. So there's a little bit of work for this. Yeah, it's a 1 mark question, but because it's a skill drawing, I will take extra precaution to this. And there's a diameter here as well. So you need to find an angle. So what do I do? What do you do here? Use n equals to sine I over sine r. Find the n first. Then find this angle and use the same formula to find r. So from this, you have I and you have r. So sub it inside. And then you can find n. Then from here, you can find a new r. Based on this. I just simply did some manipulation of algebra. Okay. Measure and state the diameter of light formed on the bottom of the disk. You should take into account the scale. All this tells you that you should take into account the scale. So therefore, you need to measure the angles. Okay, that diameter will then be this. This is what you need to measure. State one adjustment that may be made to the lens. So you have and you have like the light not meeting together. Okay, over here they meet together, but if you bring it up, they don't meet together anymore. So that's what's happening. In order for the light rays to meet together, they will have to bend lesser. All right. State one, just like can meet the lens. Okay. So if you're looking at the lens itself, they will need to bend more. The glass needs to bend lesser, but we can't change the glass. But the lens, if the lens can be changed, they could be bent more. And then they'll give you something like this. That's the general idea. So in order for this to happen, the lens would need to have a higher refractive index. Because refractive index is basically how well you can bend light. The higher your refractive index, the more you can bend the light. So the answer will be uh, replace the lens with one that has a higher refractive index. And that's it. We're done. Yay. Or another way is um, you will need to bend. Okay, do you bend more? You can raise the height of the lens. Another way is raise the height of the lens. Then that will give you the same distance as before. So way number one, change to a lens of higher refractive index, or raise the height of the lens. Okay, we're done for this. Yay.